Welcome to Session 16, Composition, Inverses, and Transformations. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to compose functions in the correct order, to construct and verify an inverse function, and to interpret horizontal and vertical transformations accurately. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Forward and reverse machines distinguish composition from inversion. Composition connects machines in sequence, and inverse reverses every step and its order. Verify that forward then reverse returns the original input. The key distinction is this: compose functions in the correct order. Then, connect it to the second goal: construct and verify an inverse function. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. For composition, start with the innermost input. Identify the object being changed and the requested result. Step 2. For an inverse, write y equals fs, swap x and y, then solve for y. Use a separate line so signs, units, and restrictions stay visible. Step 3. Verify inverses by composition. Work efficiently without skipping an operation. Step 4. Separate inside input changes from outside output changes. Whenever possible, verify with evidence independent of the original working. Signal 1 is f to the power minus 1. Respond by remembering: reverse the rule. Do not take a reciprocal. Name the response before calculating. Signal 2 is f minus h. In that case, shift the graph right by h. The form tells you which tool fits. Signal 3 is repeated input with different outputs. Remember, the relation is not a function. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Find the inverse of fs equals x plus 4 over 3. Restate the target and identify the most important part of the routine. The first move is write y equals x plus 4 slash 3, then swap x equals y plus 4 slash 3. This changes the form without changing the meaning. Next, multiply by 3, 3x equals y plus 4. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Subtract 4, f to the power minus 1, equals 3x minus 4. State what the transformed line tells you. Complete the argument. Check. F 3x minus 4 equals x. This is part of the solution, not decoration. The final answer is f to the power minus 1 equals 3x minus 4. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. Where does y equals x minus 6 squared move the parent parabola? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Horizontal signs act opposite the sign inside. Use it to repair your setup rather than guess. An accepted answer is right 6. Explain why it works and name the first step that would expose a common error. The central message is: compose functions in the correct order. Combine it with the discipline to construct and verify an inverse function. Finish by remembering to interpret horizontal and vertical transformations accurately. This turns a calculated result into a justified answer. Reflection. Explain the difference between an inverse function and a reciprocal. Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes, including a composition check. Keep the work readable, check it independently, and carry the routine forward.